Hi, it's Dr. Steve from Misericordia University. As we round out exploring the Scratch coding environment, let's look at using variables and operators with loops. To begin, let's navigate to Scratch, which is scratch.mit.edu. At our last class, we found that we could use a variable, and a variable was much like x and y in algebra or as memories on a calculator. We found that if you use the ask and wait coding block in Scratch, you're able to ask a question as the program, the application runs, and then after the wait portion, the user gets to enter something in, and whatever they enter in as their information, their response to this question, that's stored in a variable called answer. To create a variable was easy. We just said new variable. We typed the name of the variable and said OK. We discovered that you could create your own variables, as many as you would like, and when you create a variable, you can make any name and assign to it, call it anything you like, and you can use the checkbox next to the name of the variable in Scratch to put a temporary monitor on the upper left-hand corner of the stage just to see while you're coding, to see what's actually stored in that particular variable. For example, we could create a counter, and by using the variable counter, we could store numbers in there that the cat will count. And the last thing we did at our last class was we took on the challenge to make a sprite count up from 1 to 10 by using a loop and a variable. So in this block of coding, you can see that when the sprite is clicked, that we're going to set the counter to the value of 0. And we found that that's important to do because if you run this more than one time, if you don't clear out the counter and reset it to 0, it could hold any value, and the cat in this case would keep counting from that point onward. So we set the counter to 0, and then we employed a repeat loop. We said repeat 10 times. And in that repeat loop, we're asking the sprite to say whatever's in that variable called counter for 1 second. And then the next block says change that counter by 1. In other words, add 1 to it, increment the counter, and then go back because you're repeating this 10 times. So 10 times, the cat said whatever the counter was. So we found that the cat counted from 1 through 10. One other element that we could add to Scratch coding to provide more flexibility and interaction with the user who's going to be using the program that we create is called the operator. Operators are green blocks in Scratch, and you can see some of them listed here. Instead of just saying repeat or like repeat forever, we can say maybe until something is less than something else. Now remember, some of those somethings could be variables that you put in, which provides a lot of interactivity here and flexibility. You could say like if something is equal, if a variable is equal to some value, then, and then that loop will run. You could say under certain conditions where something is greater than a certain variable, repeat until that is true. So think about when you complete your Scratch coding activities, maybe you would want the operator to be able to input different information and then have the sprites act differently depending on what actions the user takes. In our last class, when we ask the sprite to count 1 to 10, and we use the repeat loop. Now we could say repeat until, and then we could drag the variable name into the operator and put a value in there. So we could say repeat until the counter equals 5, or until the counter equals 10. So look how much more flexibility that allows us, and interactivity with our student users, because we could ask the student, what number do you want the sprite to count to? And we could have that processed by the coding. For example, in an application where we want to do some drill and practice and review with students, we could ask them a question. So we'll use ask and wait. And then we could say, if their answer is equal to something, then have a sprite perform something to react to their correct answer. If we wanted to add just one more element here, an if-then-else loop, this would be an advanced way to ask a question and then to provide feedback. So when we look at the coding here, if the student answers number 16, well, then we're going to have the sprite either say something or react in some way, play a sound that's the happy sound, something that says, yes, you have gotten it right. Else, if they did not answer the correct answer, then we could have the sprite say something, or in this case, play a sound to indicate that they got something wrong. We would have them play a sad sound. So let's look at a live demonstration, and let's play with some of these operators and loops. So let's experiment a little bit. I've already dragged out some blocks of code just to save a little time. I dragged out, when the sprite is clicked, ask, and I typed in here, President Lincoln was what numbered president? Please enter a number. So we're going to ask this question, and the system is going to wait for the student to type something in. So I know that under sensing, we've got the variable called answer. Again, I can click on this checkbox if I want to view what the student, just monitor for testing purposes what the student has typed in. I'm going to turn that off for the moment. I'm going to use an if-then statement. I'll put this up here. I'm going to say, now here's my variable, and here's an operator. So this is a perfect time to be able to use an operator. So I'm going to drag an operator out and say if, and I'm going to drag notice the round in the blue variable name answer is round, oblong. I can drag it in. If answer equals, and President Lincoln was the 16th president, now I can drag this whole, notice the shape of this whole coding block will go up right in here. If the answer that the student types is 16, then do something. So I'm just going to say play sound meow. Now let's see. I'm going to go up here, click on the sprite. President Lincoln was what number president, enter a number, so I'm going to type 16. And sure enough, I got it right. Now, let me add one more piece to this. So I'm going to pull these apart a little bit. I'm going to take this block out of here as well. I'm going to remove this one. And instead of doing if, then, just take that right out, I'm going to use if, then, else. So that just adds one more capability to this coding. So once again, I'm going to say their answer is 16 if it is. So I'm going to drag it up here. If the student answer is 16, so the answer is the variable, then, so there's then, I'm going to take this play sound until done, meow. Now what happens if they got it wrong? If it's not the number 16, well, that's what's signified here by else. So it's either 16, and then then statement will take place, or if it's not, the else coding will take place. So I'm just going to drag up here. I could put a sound in or a movement. I'm just going to say, in this case, I'm going to say, that does not sound correct to me, for 2 seconds. So let's give it a try. I'm going to click on the sprite, and the sprite asks the question, and I'm going to get it wrong. I'm going to say the second president. I'll hit enter. That does not sound correct to me. So in that case, it was not equal to 16 as held in this variable. So then it skipped this line of coding, went down to the else. Let me try it one more time. President Lincoln was what numbered president? I'm going to type 16, and as before, the cat meows, and it skips the else block. So notice, with these green operators, we can plug variables into here. So I'm just going to do one more thing. I'm going to create a variable. So right here it says make a variable. Let's say that I wanted to create something called student answer. So let me just go and do it. I'll just say student response and say OK. And now student response is here. Notice the shape of it. I could now put this in any of these round oblongs. Notice it's putting it up here just in the staging area, just to show me what it holds for now. That's just for monitoring what I'm creating. I can also turn that off. So realize you can create a number of variables and use them within coding blocks within Scratch. I hope that you enjoyed our exploration of Scratch, but there is so much more you can do with Scratch. For example, if you go to the lower left-hand portion of the Scratch screen, on the bottom of the blocks of coding, there's the opportunity to add an extension. When you look at the different extensions that are available in Scratch, you can do things like have Scratch recognize student using the pen, or it can perform video sensing to recognize what the user is doing through the camera of their device. You can have Scratch translate text into actual audio speech. You can also get really advanced and have Scratch control robots and their movement. So there's so much you can do, but that's going beyond the scope of our introduction of Scratch. To wrap up this class, and also to wrap up our time using Scratch and being introduced to it, let's create a Scratch application that will do one of the following. Either allow the user to play a game, to teach them something, to allow the user to practice some skill, to do a little drill and practice, or tell a brief story. As you create this Scratch application, demonstrate the use of at least the following elements. Add at least 2 sprites. Use at least 2 different backdrops. Have a sprite change costumes. Move a sprite. Have a sprite play a sound. And for at least one item, use a loop to cause a sprite to perform some type of action or do something several times. As you're working, don't forget to go to File, Save to your computer, to immediately download a copy of the coding that you just created. And I suggest don't wait until you're completely done. What happens if the power goes out or some failure occurs? You can save, you can always load it back in again and continue where you left off. Also, when you're completely finished, then say File, Save to your computer, you'll download the completed copy, and then for our purposes you can upload that to Blackboard. this is going to end our time learning about and exploring Scratch coding. I hope you really enjoyed this experience and this coding environment. As you can figure, there's a whole lot more that you can do. If you incorporate this in classes with your students, it's a very positive experience, and you can be a STEM or STEAM teacher and support those efforts in your district. I hope you enjoyed it. Take care and see you at our next class.